Good afternoon and welcome back to the workbench. Today I have something a little bit different than usual. It's an electric razor shaver sort of thing. Um, this is maybe obvious or maybe not obvious, seeing as it's in state of disassembly. But anyway, I was given this to have a look at, and with the complaint that it wasn't working properly, wasn't really doing any shaving, and switching it on, there's a button there. Powered by these two batteries. Switching it on, it worked fine. Well, it didn't work fine. It made a noise. Seemed to work fine. But the this blade assembly here didn't actually go back and forth. It's supposed to go back and forth behind this this grill thing here, and obviously shave hairs off. But it didn't actually do that. This thing just sort of stayed stationary, and it just made a buzzing noise. And at first I thought, well, maybe there's some kind of linkage that's snapped. Because apparently this is about 15 or 16 years old, and I kind of thought, maybe there's some kind of plastic part that's just snapped over time or worn out or something. I was kind of thinking along the lines of a PlayStation 2 worm drive or whatever it is for for the laser assembly. I remember one of my friends, he had a PS2 that gear had worn out on it, and it couldn't seek the laser properly, and it couldn't load games. It would sort of get halfway through running something and just lock up. And I think that was a common problem. You could buy the new gear assembly on the internet and replace that if you wanted to. And so I just kind of thought maybe it was just that. It was just like a nylon gear had just worn out, or something had broken. But so I took the thing apart and had a closer look, and it turned out that wasn't actually the case. I thought maybe the motor might be worn or something, but the actual fault appears to be that this little, well, I don't know what you call it, sort of cam sort of thing here, that sits over the end of the motor shaft and creates an offset rotation on this pin at the top, which drives the thing back and forth. But it turned out that just basically when I took the motor out, this little thing just fell off the end, which obviously is not supposed to happen. That should be firmly attached to that drive shaft there, and it shouldn't do anything like fall off. So it became pretty obvious that by just holding your finger on this and turning it on, the thing would just slip. So the shaft of the motor would just slip inside the hole in here. And I guess basically what happened is over time it just became loose, and then as soon as this started slipping, when the motor was on, it would just obviously just start spinning inside there and sort of wearing it more and more smooth, and so it would just slip even more. So yeah, it just seems to be sort of a cycle of self-destruction in terms of failure mode. But yeah, the thing seems to be that's the problem. So basically, I have to try and get this gear or cam or whatever it is back on this motor in a good fashion, which I'm not entirely certain how to do that. I mean, I don't know how they would have put this on at the factory. I guess it would be an interference fit or a friction fit or something. They generally don't seem to be welded on or anything. In some cases it may be crimped on, for example, but I don't think that's the case here. There doesn't seem to be any sort of tooling marks to indicate that that's what's happened. So I think it's just like a friction fit or something, and over time it's just worn down and started slipping, and then the slipping has just exaggerated the wear, and it's just gone to the point where it can't drive the thing at all. So I figure the best option I can think of is to use this stuff. Good old J-B Weld. I've never actually used this before, but as you may know, it has metal in it. It's like a steel epoxy thing. Can withstand high temperatures. I mean, I do have other epoxy that you could use on here, I guess, but I just wonder if after extended use how hot this motor will get. Maybe it'll start weakening, I'm not sure, but the J-B Weld is apparently good up to about 200 degrees Celsius or whatever, so that should be more than enough. So yeah, I guess I'm just gonna glue this thing back on here with this, and hopefully that works. Yeah. Anyway, the instructions say to rough the surface of this, so I can probably get a little file in and file the surface of that drive shaft there. I'm not entirely sure what I can do about the inside of this though. I don't really have anything. I mean, I've got some little small files, but I don't know if they'll really be able to do much. I can give it a try, I suppose, or you could even maybe just get like a sharp pointy tool and just sort of scratch around in there and try and get something. But yeah, we'll see. I guess we won't need very much of this, just a tiny amount, but yeah, we'll just see how that goes. Hopefully. I mean, the thing is 15, 16 years old, so I guess it's lasted quite a long time, and yeah, it's kind of interesting. The only real major wear or failure to it just seems to be this here. I mean, the motor itself seems to be running quite well and quite strong. So yeah, oh yeah. And for the record, this is a Panasonic. You can see this Panasonic ES117. Looks like it's from maybe China or Japan. Obviously not a European market item. But probably, I'm sure it's the same as ones found in other countries, just maybe a different model number or whatever. Same basic concept. Anyway, so I'll try and do that, and we'll see what happens. Hopefully it'll work. So I'm just going to try, use these maybe a little tiny little rat tail file here. I suppose you could also use sandpaper, but I think this should work for, just sort of get on here and make a little bit of filing on there to roughen the edge there, so that the epoxy can have a good surface to grab onto. Obviously, I think you do that probably upside down here, so all the filings can fall off. You wouldn't want them to fall into the motor and cause a problem. So yeah, that's one thing to do. And obviously when you glue this on, it would make sense to make sure you don't get any glue down the shaft or something. You'll just glue the motor up, so that won't work either. So yeah, be very careful, be very sparing. That's what I'm going to be doing. Make sure I don't use too much stuff at all. I mean, the thing is practically a tight fit on there as it is, so I think there'll be hardly any glue necessary. But yeah, just try and do that and see what happens. So yeah, I guess holding it upside down and even just go straight up and down maybe. Just put some score some lines in here basically. And I'm just kind of running this around here because of course this shaft will try and turn if I try and file it that way. It's just going to spin around, so just sort of make some scratches in there. I don't know. Sort of turn it into kind of like a knurled shaft basically, I guess. So I don't know if you can see that. Maybe I can get this over the top. So you should see there's some kind of lines scored into that. So you got something there that the epoxy can sort of grab onto. I guess up to you how deep you make those or something, but yeah, I don't know, should work. Something to make it a bit rough. Hopefully. And then try and do something with this sort of concept, I guess. I mean, I can grab this really little fine one and get that in there. Maybe I can do the same kind of thing. Just sort of scratch around in there and roughen the surface up. I've already cleaned this with the circuit board cleaner to get the grease off and make sure there's no residue of anything that'll stop the epoxy. I mean, I don't think it would be greasy in there anyway, because all the grease would be on this side and there wasn't very much to begin with, but you know, just in case. So I'm just going to scratch it out a bit. You know, hard to get this on camera obviously, but you get the idea. Just sort of, you want to just scratch the surface up there so that you've got something for the epoxy or glue or whatever to get into. Make it be able to grab onto something. See if I can actually see anything in there. Yeah. Yeah. You might be able to see that. You can see I've sort of made some score marks on the inside of that. Again, not very deep, although this metal is much softer than the drive shaft on the motor, so it might be easier to do. In fact, that's probably what's wrong with this, is that it's such a soft metal, it's worn out faster. Don't know what this actually is. Some kind of cast aluminium maybe? I'm not sure exactly. Anyway, that looks like pretty much the concept. And let's just mix some of this up. So I've just got to find something to mix that with and mix it on. Don't have anything right at the moment. Let me find a bit of plastic bag or something. Yeah. There we go. Piece of plastic sheet there, that should work. Where's the thing here? So, I mean, we got that there, the instructions here. If that would focus. Anyway, clean repair area of dirt, grease, oil, paint, etc. Also says somewhere. Oh yes, for best results, use a degreaser or detergent to clean the surface, roughen the surface of the file, or coarse sandpaper. So yeah, there we go. Squeeze equal parts of that, apply it, mix it together. It cures in 24 hours, so yeah, just leave it all day till tomorrow morning. Anyway, it's the usual kind of thing. Most epoxy works like that, as far as I'm aware. All these two-part ones anyway. So yes, let's have a look. And we obviously need in terms of this, we need pretty much next to nothing. So, you know, Yeah. Just take one of these cotton bud things and cut the end off. So I've got a plastic stick. Mix some of that together. Smells terrible, of course, as you'd expect. Smells like old cat piss. I don't know why these things always smell like that. Seem to often smell like that anyway. Here we go. Got a bit there. That's plenty of it. Okay, I'm just going to put that to the side there. Just have another look at this. Make sure it's... looks like I've done enough to that. I think so. I think I've scratched that enough to make it fairly good. Hopefully, anyway. Right, so I guess to try and get it in that hole somehow, which will probably be the fun part, actually. I think I need something a bit thinner. Maybe... maybe some wire. I'll take one of these old, like, twist tie things and strip the plastic off. Get the wire in the end, and if I just get a little dab on there, you can see, very small amount. Should just be able to stick that in there. So I'm just kind of dabbing that in there. Interesting. I see there's like a hole that goes through. So when I stick this on, it may all squirt out through the hole at the base of this. I don't know if you can actually see that. If I should bring this out a little bit. I don't know. Not sure that makes much difference, to be honest, but there we go. Anyway, so we got that there, and hopefully just push that on here. And just trying to make sure it doesn't all squirt out down the bottom there and cause any sort of problem. Maybe I should even wrap some tissue paper around that and just to be sure. Alright. Let's see. So Gonna take some paper here and just wrap that around the bottom of that. So when I squeeze this down, if any squirts out the bottom, it's not likely to go all over the place. I think the amount of scratching I did on it has actually made it fit quite tightly anyway. But yeah, anyway, that seems to look alright. So yeah, I guess the basic thing is just to leave that for 24 hours and come back and see if it's worked. Kind of be surprised if it doesn't, to be honest. I think it'll work quite well, but we'll see. We'll see what happens. Yes. See you in about 24 hours, I guess. Okay, this is actually about 1 minute later. I just noticed this was not sitting down as far as it should have, so I just tapped the top very lightly, just with a hammer, basically, just until it sat down to the right level. And yes, some of the J-B Weld did come out that hole at the top. If I get that on there, you can probably see that little hole above the number 7 there. So some of it did come out the top there, and I wiped that away with a tissue. And at the bottom you can see it's much closer down there. So that's obviously the correct point there. And we can see none came out the bottom, which is good. So there we go. Yeah, like I said, leave that for 24 hours and hopefully that should be done. See you in 24 hours, this time for real. Hopefully, anyway. Alright, so it's actually is 24 hours later this time, or maybe 23 or 25, I'm not sure. It's about 24, which is what the time was. So, yes, so it's time to put this back together. So I'm just going to reassemble it and talk about how it came apart as well, so you can sort of understand how to do that, seeing as I didn't show that in the beginning. Also worth noting that I've put the little O-ring back on here. There's a little O-ring, I guess, to reduce friction or something. And that just goes on there. I've added some extra grease because I cleaned all that off before when I was cleaning everything up to glue it back on, so I just used some more grease to put that on. But yeah, the design of this is actually quite nice. It seems to be very modular and sort of made, kind of makes me think it's actually made for repairability, because it is very easy to take apart and very easy to put back together. So replacing any one component in this is not a very complicated job. So I kind of wonder if that's the case, and maybe it makes sense because this was made quite some time ago. Like I said, maybe 16 years or maybe earlier. I think that's how old this one is. The actual design might be 20 years old or something, who knows. So in terms of yeah, I mean that would make it around early 2000s or maybe even earlier, back when people actually still seem to care about making things repairable. So that's quite interesting. But yeah, anyway, so this motor here just slots into this little thing where the batteries go, making sure this yellow tape is on the top here by the switch contacts so that nothing is likely to short out there. That just sits in there, and the motor contacts just push up against the back side of these battery contacts and through the switch. So it's pretty simple. Anyway, switch itself is just a little plastic thing in there, just a little sort of half circle thing that rotates when you move the button. So let's put that to off position and slide this just on here. Should just go on fairly easily, and just check to make sure the switch moves. It does, so that's good. And then there's 2 screws that go into these 2 holes here, not these ones up here, that's for holding the top on, but the 2 ones there, these are these really long screws. So those go in there like this. You've got these 2 there. And yeah, it's just a case of screwing those in, which takes a while, but gets there eventually. To get these out, you may need a rather thin screwdriver because they are down the side of this plastic and there's not much clearance. So yeah, in fact, to get them back in I might need a thin screwdriver too. But to just do the main work, because they're so long, I'm just going to use this one, but you can see now it's hitting on this plastic, so I'll just get another screwdriver set. It is kind of annoying because they don't have a small head on top. They have a rather sort of large, well, relatively large for the size of the screw thread anyway. So to get this, I wonder if this will work. Yeah, there we go. See, even that one is sort of not yeah, it works, but it's that one's a little tight. It's not the easiest. You need easiest to get in. I mean, I've got another screwdriver that has a nice thin shaft to fit in there, but it has a much finer point, so it just slips. It doesn't even drive the screw. So yeah, and it's not the kind of screw you wanna strip out either, because it'd be hard to get replacements of that length and that sort of size. Probably not impossible, but not exactly easy. So yeah, you don't really want to damage those if you ever want to take this thing apart again. But there you go. So that just screws onto there. Pretty simple. And then we got this little bit here. This is the mechanism that converts the rotational motion of the motor and the offset shaft thing into the back and forward for the shaver blades. And it's got this little linkage thing that just fits on top of that and goes to and fro. And initially I thought that, it'd be something like this plastic bit here that might have worn out or snapped off or something, but as it turns out, it wasn't that at all, which is kind of surprising me. But yeah, so that just sort of slots down on top of that, and it's kind of tricky to do because you have to kind of come in on an angle. It's kind of strange. So I found the best way is to just sort of sit this basically on there and then sort of get like your pair of tweezers or pliers or something and just push that bit there down on there, just like that. So once that's on there, it just sits there like this, and these top bits, and then this bit here goes over the top. So this little rubber seal here, so we just keep the water out. The same for this O-ring on this bit. So that goes down into here, and you have to get this rubber seal out through the top there. So I found the best way for that to take like a blunt sort of thing, soft plastic, and just make sure you've got like at least one corner of this sticking through the top when you put it on, and then it's just a case of sort of lifting the rest through, and then it just will work quite well. See, once you get that sort of get that so that it's flipped up. Don't want to use anything sharp on this, so you risk tearing the rubber, obviously. There you go. Push that up there. So this sort of folded bit in the middle will sit in here, and then that will sit in this lip, just like that. So looks like this is actually right here. So make sure that's sitting correctly on that bit there. Seems to be. Excellent. Okay. Make sure that's straight up and down. It was a bit crooked just before. So yeah, and then we got this little bit here. Oh, and I meant to mention, yeah, so this bit there with this gap in it, sorry, this is not in focus, is it? This bit with this gap here goes on this side for this hole, for this little release button for the top cover, and that side just has just a little clip on it. So make sure you get that around the right way, otherwise it won't work either. And then this you can just push back in by just getting the spring in there and just pushing it in. If I can figure out how to do that. There we go. So it just pops in there, and that's how this bit, goes on the top there, and then you can just clip it on and off. So the next bit is to take this plate here, and that goes down on top of this. And again, we have the same thing. This rubber bit in the middle there sort of just pushes through there, like that. Let's just make sure that's not pinched or anything. That should work. And then we got these two screws here that hold that down. The steel screws. Well, the silver screws, I guess I should say. Makes more sense. Okay. So that just goes down there like that, and yes, so I'll just do a quick test to make sure this thing is actually functioning. I'm just going to put these on. You can see that goes to and fro, as you'd expect, which is what it should do. So that's good, that seems to be working just fine. So then we got this little bit here that goes on top of this. Now this was the hardest part to get apart when I took it apart. This just sits on top of here and just clips on. And I believe this drives some part of this in here, although I don't know what that actually does, but does something. But yeah, to get this off, originally I found the easiest way, I think, was to get these pair of pliers and sit that underneath this and just sort of push it off. You don't want to like lever, I think, on one side or something, because I think this will probably snap. So you want to get it, make sure under both sides at once, right in the middle there with a pair of sort of thin pliers or something. Should work, because it does sort of clip on quite tight once it's on there. But yeah, and that's just a case of putting there's a little spring in the top of that, putting this blade head on top of that there, and yeah, this just goes on top of that, and this can go up and down. I'm not sure exactly what that's for, but it seems to do that. If I put the batteries in, it would actually turn on. Okay, put that in there. Put that back on. Let's see. There we go. I'm guessing that works. I don't actually know, but there we go. It's all back together and it's making the right sound. I don't know if you can see, but the blades are definitely moving back and forth, which they weren't doing before. Basically, the previous issue with this was that it would work fine like that. That would definitely work there, but as soon as you put this top back on, the friction of the blades against the guide or whatever it is would just make the motor spindle slip and nothing would happen. It would just make a mild humming noise and the blades wouldn't move. So now they do move. So I guess it is fixed again, which is pretty nice. So hopefully, if the J-B Weld stays nice and welded, everything should be great again. So yeah, it's something a bit different, but it seems to be a good fix. So hopefully that'll work, and yeah, hope that was interesting, hope that was useful, and I'll see you next time.